Welcome to today's class on real numbers. In this session, we will learn what real numbers are, understand the fundamental theorem of arithmetic, and learn how to find HCF and LCM using prime factorization. So, what are real numbers? Real numbers are all the numbers on the number line. They include natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Let's see them one by one. Natural numbers are counting numbers, that is 1, 2, 3 and so on. Whole numbers are natural numbers along with 0. Integers are whole numbers along with negative numbers. Rational numbers are fraction that can be written in the form of p by q, where q is not equal to 0. For example, 1 by 2, 3 by 4, minus 7 by 2. Rational numbers can also be written as decimals. They may be terminating decimals or non-terminating but repeating decimals. For example, 0.5 and 2.75 are terminating decimals, while 0.333 and so on and 1.2727 and so on are non-terminating but repeating decimals. On the other hand, irrational numbers are non-terminating, non-repeating decimals, which cannot be written in the form of p by q. Examples are root 2 and pi. So, we can conclude that real numbers are the combination of rational numbers and irrational numbers. Now let us understand the fundamental theorem of arithmetic. It says that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Let's take an example 32760. We will start dividing it by the smallest prime number, that is 2. 32760 divided by 2 gives 16380. Again dividing by 2 we get 8190. Once more by 2 we get 4095. Now 4095 is not divisible by 2, so we go to the next prime, which is 3. Dividing by 3 gives 1365. Again dividing by 3 gives 455. Next 455 is divisible by 5, which gives 91. Now 91 is divisible by 7, which gives 13. And finally 13 is a prime number, so we stop here. So if we collect all the prime factors, we can write 32760 as 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. Now instead of writing the same number repeatedly, we can use powers. So we write 2 to the power of 3 into 3 to the power of 2 into 5 into 7 into 13. From this example, we see that every composite number can be expressed as a product of prime numbers, and this factorization is unique apart from the order of the primes. Now let us learn about composite numbers. A composite number is a positive integer greater than 1 that has more than 2 factors. For example, the factors of 4 are 1, 2 and 4. The factors of 6 are 1, 2, 3 and 6. Here both 4 and 6 have more than 2 factors, so they are composite numbers. On the other hand, if a number has exactly 2 factors, 1 and itself, then it is called a prime number. For example, 2, 3, 5 and 7 are prime numbers. Now let us learn how to find the HCF using prime factorization. HCF stands for highest common factor. To find the HCF, we first write the prime factorization of each number, then we take the common factors with the lowest powers and multiply them. Let's solve an example. Find the HCF of 48 and 60. The prime factorization of 48 is 2 to the power of 4 into 3. And the prime factorization of 60 is 2 to the power of 2 into 3 into 5. Now to find the HCF, we take the common factors with the lowest powers. Here the common factors are 2 and 3. The lowest power of 2 is 2 to the power of 2 and 3 appears as 3 to the power of 1 in both. Multiplying them we get HCF is equal to 2 to the power of 2 into 3, which is equal to 4 into 3, which is equal to 12. So the HCF of 48 and 60 is 12. Now let us learn how to find the LCM using prime factorization. LCM stands for lowest common multiple. To find the LCM, we first write the prime factorization of each number. Then we take all the prime factors with their highest powers and multiply them. Let's solve an example. Find the LCM of 48 and 60. The prime factorization of 48 is 2 to the power of 4 into 3 and the prime factorization of 60 is 2 to the power of 2 into 3 into 5. Now to find the LCM, we take all the prime factors with their highest powers. Here the highest power of 2 is 2 to the power of 4. The highest power of 3 is 3 to the power of 1 and 5 appears as 5 to the power of 1. Multiplying them we get LCM is equal to 2 to the power of 4 into 3 into 5 is equal to 16 into 3 into 5 is equal to 240. So the LCM of 48 and 60 is 240. Thank you for watching.